Okay, we are back. We're back. And today's going to be how to cut STL files, miniature files for 3D FDM printing. And yeah, it's a thing. And we're going to see if it ends up working. So yeah, welcome back to The Varied Life. I'm Steve, the hobby tech guy who's American expat, retired here in Korea. We're doing 3D printing, we're doing miniature painting, we're just kind of doing hobby stuff, besides the other varied things in life that goes on. With that being said, I've had some people contact me asking about how do I print miniatures and tabletop miniatures, doing things like that, and or larger versions of miniatures. That's kind of a big thing for people that are into tabletop gaming, and usually you use a resin printer to get the most details that you can out of a miniature or an STL file. But with that, some people, hey, I want to make it bigger, but I keep having failures on my print. So how can I alleviate that? Well, that's what we're going to talk about today. So with that being said, I found some pretty cool stuff that I wanted to print out, and I scaled it up, tried to print it normally. So that has been problematic. And so what we're going to do, so for example, we have this guy here, which is kind of a cool looking character. Pretty involved, a lot of details, a lot of spindly little parts on there that, if you put that into a 3D printer and tried to print that, you might have some problems. Believe me, I know. But the other thing we need to look at, especially with STL and miniature files, is these are often brought to the point of where they are broken down into smaller pieces like we see here. Now that's a lot of smaller pieces, and even then, that makes it a little bit easier to print these out, but still there are problems. And so I was searching for a way to be able to do this, to print these out, because yeah, I want to print a bigger one, and I was like, how can I print this to get the most success? Instead of, and we'll just dive right into it. So yeah, that's a cool looking figure that we want to do. We want to check that out. And we're going to do this in Creality Print, which is the software that I use. And let me make this a little bit bigger. We'll just kind of put this here, and we'll make that a little bit bigger. We'll move this guy over here down to the bottom. Do a little bit of house cleaning. So what we have here is our model. And as we've seen, we have a bunch of different pieces and parts, and, trying to print these out, usually what you would end up doing is you'd probably let's take this one here. And we want to face that somehow. And those are the areas of which we could try to, kind of put that on the board and try to line that up. And of course you're going to have supports. You have minimal contact on the bottom here, so that's going to cause some problems. And seeing that it's orientated like this, you're going to get some scarring on this side of the model, which is a visible side of the model. So that's going to cause you a little bit of problem right there. And then with some of these other things, how in the world are you going to print some of this stuff out? When you look at that torso, or you look at the head that we have there, holy crow, how is that going to work when you see, yeah, that's just kind of crazy. And again, if we move this into a position where it's straight up and down, you're still going to have minimal contact with the base. And again, it's just going to have more opportunity for the print to fail. So this is printed up at a 200%, I think a 200% increase. And we got Ferrithus here. Good morning, sir. Good morning. Yes, it is a good morning. It's currently 8:25. I'm going to be a little late to the gym today. The wife's not going to go, so I'm going to go a little bit later. So I figured, why not make a video and share this information? Maybe it'll help you out. You can give it a try and see what happens. So with this, if I try to slice this up, and we're going to get a lot of supports, we're going to print this at 0.16 layer height using PLA, matte PLA. We're going to use some supports, tree supports, those are probably the best to use with miniatures. You get the more bang for the buck, and it is good. Ferrithus says that he already introduced a new arm day on Sunday. Cool. Yeah. Getting the arms in there. So what we end up seeing is this is going to be 7 hours. It's going to be like $1.57. So, but when you print something like this, again, you're getting some stuff to where you've got a ton of supports on like some floating regions. You got a ton of supports there, and the problem with that is you're going to have some marring on one side. And what I found, oh, and then look at this. I mean, this cape and everything that's very problematic because we don't have any direct contact points for that cape, kind of like what we do on here. So we have the base there, that's nice and flat, and so that's easy to print, okay? But I'll tell you for a fact that you're going to have problems with printing this. I have problems with printing this. I dialed in my filament, and yeah, it's just not working out. So I was like, okay, there's got to be a better way to prepare it. Ferrithus says, printing all that in one go, you're brave. I'd be scared that it fails like 10 hours in with so many complex parts. Yeah, and that's exactly what happened. I did smaller versions of this, and I did one larger one. Already had fails even before it got many hours into the print because of the intricacies and the details and so many supports. It's just, it's very problematic. So what I ended up doing is I was like, okay, well, flat surfaces are good for the most part. But in this case, we want flat surfaces. We want the model to have a flat surface to contact to that build plate. So as I was thinking about it, I was like, okay, well, we got the base there, and that has a flat surface, and so that's going to print out pretty good. It's got some overhangs in that, but the tree supports will do all that for us. But on all these other pieces, I was like, man, what could we end up doing? And then I was thinking about the planer cut. The planer cut is our friend. So if we orientate this, how it's kind of like that right there, we can kind of go through and, we could try to do that so that it builds upon each other, but then it's kind of weak. And yeah, I don't know. We're just going to kind of leave it like this. But we're going to do a planer cut, and we're going to make some flat surfaces so this thing will print. So we'll go ahead and we'll go to our planer cut. I really don't like that floating window. And we're going to go ahead, and we're not going to cut it that way. We're going to cut it, if I can grab that, and we're going to go to 270 degrees. And we're going to split this baby right down the middle. And so I think that's close enough. There's some minor things that we could end up doing. We could try to get it to where it's just perfect. And then we could move that so it's pretty much down the middle, kind of like that. Okay, so we got one side, we've got the other, and then you could just cut it and then print it out and then glue it. But the other thing we could end up doing is adding some connectors. So these are going to be small connectors. We've got 2.5 millimeter for depth and size, and our little variance here is going to be 0.2 millimeters. So we could just throw a couple of these, and these are dowels, and we'll just do a triangle there. We'll do a triangle there, and we'll do a triangle there, just for the hell of it. And those are the connectors that we want. And if we look on the other side, we should be good to go, because we want to make sure that those triangles are not too long and go out the other side of the model. It will show up in red. But those look pretty good. So we're going to go and we're going to confirm that connector and do a quick little once over. It seems like it's good to go. And we'll hit perform cut. It'll do its thing. And what we end up having is this right here. So this flat edge is already set up on that one. And so we're going to go to this one, and we'll select that flat edge. And so now, And then we've got our little connectors on there that will print. And so now we have this nice flat base of where this model is going to be printed from. So when we end up slicing this plate, hey, we got Swedish Forge in the house. What's up, bro? How's it going? Good to see you. So when we slice this up, and what we end up seeing here is now we've got a lot of contact for that model that is flat, and it's not going to be any problems with this. We're going to get some good strength out of it, some decent strength. Yeah, 2 or 3 walls, whatever it is, 5-10% infill gyroid. We've got minimal supports on here that should be easy to take off because we set the top Z distance at 0.25. So that is how we can do that. So again, if we go through we could just split these models in half. So again, we'll just do a quick little one here. And we'll just kind of zoom in and we'll bring that, and it's close enough for government work. We'll add a connector on there, add a couple of connectors, confirm those, do the cut. The cut is good. And there, this one piece that's right there, that's already flat on the build plate. And this one here, we'll just put that flat on the build plate, and boom, we're good to go. And then we got our 2 little connectors on there, our little dowels, triangle dowels. That'll help us line up those parts, and that'll be good to go. So we'll be able to do that. Now the problem comes into play when we have some more complicated parts, like this here. This cape is going to be really, really interesting in the fact that, let's see if I can, what am I doing? There we go. That this is going to cause some problems because with this, if you normally print it like this or you try to angle it up, you're going to have a ton of supports, which is going to introduce a lot of failure points or possible failure points because you don't have a flat surface where this can contact the build plate. So once again, what we're going to end up doing is we're just going to orientate this a little bit. And we'll just kind of go like so. And what we want to do is we want it up like that or something like that. And then we're going to go through and we're going to drop this down to about right here. And so what this will allow on the blue portion at the very bottom there, that will have contact with the build plate. And then conversely, on the pink part, even though we rotate that upside down, it'll have a flat surface in contact with the build plate to build off of, and we'll have minimal support. So we'll have good contact with the build plate, and things will be good. So if we want to go ahead and we want to do, I don't think a triangle is going to work. I think we're going to have to go with like a circle. Even that's kind of rough right there. So I'd probably, let's make this 2, and we'll see how that looks. So we got one there, and we'll just put another one over there just to keep it simple. So that's where we got it. We'll confirm our connectors, and then, as we see here, we'll go ahead and we'll perform the cut. This will make it good. So we can see that this piece here is in contact with the build plate, and we will have minimal supports. So we'll have a good foundation, so that'll be good there. We've got our 2 little dowels, and then with this piece here, all we want to end up doing, see now we got a great flat surface, and boom, that should build up, and I doubt we'll have any supports on that. So you could do something like that. Let's go ahead and rotate this just a wee bit. So we just, and now we're going to get into something a little bit different. Because you'll run across STL models that will have things like this that's going to be very problematic. I tried printing stuff like this a few times and it just doesn't work. Just too many failure points. And again, it kind of depends on the model. Like here, the details on the legs are really hard. You're going to have a lot of supports from the floor, the build plate onto that foot. It's just not, you've got this whole thing, this little loincloth metal thing between the legs. That's going to be really hard to do. We want something that will give us the best opportunity possible. So again, we're going to use a planer cut. And this, we can bring this up because we could do something probably somewhere around there. I think that'll be pretty good. So we'll do something like that. Again, we'll go back and we'll do our connectors. With this, we'll go ahead and we'll make this like 4. No, we'll make, do that 3. We'll do this one 4. And we'll go back and we'll just do a triangle. So we can put a triangle there, and we could probably hold that in place, or you could put a really, really small dowel. We could do something like that, but for the sake of this and just getting a little bit quick into this, we'll just go ahead and do that. We'll perform our cut, and now we have this piece here, which again has a nice flat surface, and we can build up from there. So we're going to preserve all of the details. If it's leaned over at like a 45-degree angle or 30 or whatever, you're going to have marks from those supports on that model. With this, we'll get minimal support scarring. We've got our 2 little triangle dowels. And then with this, we could just do that. And now those are pretty much, you're not going to need very many supports on this. And so, and you could go ahead and do the same thing, with a piece like that. You could rotate this kind of an up position like that. And we could cut this. Again, we're just going to go that 90 degrees. We'll just kind of move that just a hair. So we try to get it down the middle, or, something like that. And again, you go ahead, we'll just add 1 connector, confirm, we'll cut. And this doesn't take a lot of time, which is the good thing. So again, that one's all squared away. This one, we'll print this on the bottom. And again, it just makes it so much easier. So now, if we slice this plate up, it'll work. We got George here. Hello, George. How's it going? Talking about how to improve our odds of printing miniatures in the STL files on an FDM printer. I don't know. Maybe it's cheating. I don't know. And instead of trying to do and have that mini printed, in an orientation that's going to have a lot of possible failure points because you're relying on those supports, what we're doing is we're maximizing the amount of surface contact of that model when we split it in half, and we have minimal supports, and we got a better chance of this stuff printing out. Things like that, even the cape and everything. This cape doesn't even need any supports. We'll need supports here, obviously, but it's a lot less than what we needed before. And with these legs, let's take a look at these. Since it's going up, we've got minimal supports, and I'm not too worried about that. So that's basically how I ended up doing this, is cutting up the model. We scaled it up 200%, and it should look pretty good. This is going to cost me $1.65, and this is 6 hours and 56 minutes. So yeah, it seems pretty good. There for a moment, the model looked like it had an enormous Franzstücker. Okay, I'll take your word for it. Franzstücker sounds almost like German, and in that case, quite dirty. Yeah. So apparently, yeah, his Franzstücker, which is that thing right there, we don't have, it's going to build up because we have that flat surface on which to build from, and then we have minimal supports. So yeah, that's going to be our model. And the cool thing is, I just so happen to have this printed out. Oh, Young Frankenstein. Oh, Frau Strucker. Hear the horse in the background. Ah, yes. That is a good one. That is a good one. So anyway, I just happen to have that model. So if we take a look there, ooh, look what's on the table. Yes. Doesn't that look good? So what we're going to do is we're going to go over there and we're going to take a look at that and see how that printed out. So yeah, love the movie. But it's very different now. If you watch it now, it's Young Frankenstein. There are some funny parts, but I don't know. I guess it's because as you get older, you know, you grow, time passes, and there's stuff. It's just as fun as that movie was. I recently watched it. Well, I wouldn't say recently. I'd say a couple of years ago. I watched it again, and it was kind of like, I mean, there's still a lot of funny parts, but it wasn't as funny as I remembered. Maybe it's kind of like when you were living at home, and then you go out into the world, and you come back, and then you go back to that home that you grew up in, and you're like, wow, this is really small. Yeah, your perspective changes. So what we're going to do is we're going to go over here to the build station, and I think we could just do this here. So we'll just kind of throw that up there. I'll put this on this side here to keep that out of the way. And maybe make it a little bit bigger. And we'll see how this works out. So we will migrate over and we'll get everything set up here. Let me get my tablet going so we can get that, and we could do that. And now I got that going. So yeah, here is our model that we have printed out. It just finished up, and as you can see, we got pretty good. I should have angled this a little bit more because I've got a lot more supports on this one, but it was kind of late yesterday and I wasn't. So yeah, we've got some pretty good stuff here. So let's go ahead and we get our base nice and smooth, and we can get these little supports off. Dun, 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 dun. Let's see how this came out. So yeah, kind of good that we're able to get all this stuff going. And of course we've got, that's probably something I should have done, is taken these supports and the bottom Z distance. I should have set that a little bit different. Okay, we got a little bit of stuff there, but not too bad. Not too bad for the base there. I wasn't too concerned about the base. That would turn out good. I think I need to play with the bottom Z distance. This is the magic of TV. Like in the baking shows, you prepare, push the magic button, and the finished product. Yes, exactly. Yes, definitely indeed. Let's see. So here's the other part of our cape. And these are coming off a lot better. And so we got some pretty decent looking stuff. Got a little scarab on there. Little supports. But yeah, with that flat distance, that flat surface, we're able to get some real good details on that. So yeah, that turned out well. So there's that. Here's our other one. And again, we've got minimal supports on here. And boom. So I could have done this a little bit better, but like the one we just did on the computer, and we can see that when we add that on there, we just do a little bit of gluing and boom, there would be our, and we do have the holes, but these holes were a little bit too big, so that was my fault. I could probably just do it without connectors, and you know, we end up with our cape on there. So yeah, a little bit of glue and we would be good to go on that. So that came out good. In some ways a 3D printer is propelled dream machine, set it and forget it. Oh yeah. Or the Ronco, set it and forget it. Let's see if we can get some of these off here. Got some supports in there that are a little problematic, but we can dig those out. That's not a problem. But with the complexity of a model like this and trying to print it like you would in a resin printer, you would have a lot of problems. So yeah, this definitely seems like a better way to go. If you're looking to print this stuff out. And then when we join all those things together, we should be good to go. Again, we're going to have to dig out some of these. But like I said, it's so much easier, and the chances of getting a good print by splitting the model in half is going to be so much better. So again, we can put this together, and we've got our holes and everything. So when we put this together, boom. Let's see if we can focus on that. Focus. There we go. Oh, come on now. Work with me. So we can see once we glue this together, I mean, this will be pretty good. And the lines of where that planer cut is actually not bad at all. If you can see that. And then by the time you've got this all glued together, and then if you're going to paint this, you'll put on some 2-in-1 primer or whatever, very minimal amount of post-processing. So again, we can get some really good stuff. Let's see. Let's get one of the bigger items here, which will be the foot. And the problem that I had with trying to print it in an upright position is that you had some details on this foot, kind of like this back Achilles tendon would always break off. And we're going to do a little bit of surgery here, so that way we can preserve our details and make it easier. And then now we're able to save that Achilles tendon that we have right there. So yeah, it's all in the orientation and the processing. And we get minimal scarring, a little bit of cleanup, which isn't bad. Okay, get off of there. See if I can get this without breaking that Achilles tendon. Which we're getting pretty good. And boom. There is our foot. So we're able to get this, and we have the Achilles tendon on there, and we got some good details. So a little bit of marring on there, but not bad. Compared to trying to print this in this position, that would be problematic because that's a really small part that we have there. So again, and then we have his Frau stripper. Again, we got that, so that came out nice. And then his other foot. And again, we got the same thing. So we're going to strategically remove these. So that we don't have any problems. Got some little mouse ears that I put on there. And our little operation thing here. This is turning out pretty good. And there is our foot. So minimal cleanup, a little bit of scarring, but nothing that can't be like just trimmed away. And if I had the, if I went the other route, the probability of trying to print this in an upright position without doing the cut on this like we did, I'd get a lot of fails. So yeah, that's what makes this great, is that we have that flat surface, and again we have all of these other pieces. So definitely what we can end up seeing is this is a preferred way that seems to be working out pretty good. And ooh, this is going to be an interesting one. Okay, so we got that. So yeah, this is turning out well, which is good. There's our other little piece that we just did. So these are two. Some little dingleberries there. We got our little hole that we can get out. And then when we put that together, and boom. So there it is. Yeah. And we just got to make sure that we get that lined up, and we will be good to go. So this seems like a viable solution to printing miniatures And you could probably do this on a smaller scale as well. So normally miniatures are like 32 millimeters. This one would be a little bit bigger, but and I scaled it up 200%, but it still works. So that's the good thing about it, is you could still do the planer cuts. You could still get all of this stuff going and you will be good to go. So like with our feet, how does this one go? This one goes on this side. Clean that off. And nope, that one goes on that side. So we can see now we could have the part of our torso together like so, and then we have our other foot. We just glue that on there and we'll have that and we'll be good to go. So yeah, a complex part that if you tried to 3D print it like this on the build plate or angle it back, you're going to have a lot of marring on the back of the model and you're increasing the possibility of a failed print. So doing it this way, again, I'm really, really pleased with the results that we're getting. And even smaller parts, like this here, part of the arm. Let's see if we can get this off of here. Again, we split this thing in two. And boom. There is our arm. So we got that going. Some comments. You would have been all over it. You have steel nails. You don't need tongs. You say that until you get until you get filament in between your finger and fingernail. And this is the headpiece that we split. So we got half a head here, so that's pretty good. And we'll get the other side. Got little mouse ears. I use mouse ears on this so that way we could still, you know, kind of contain the model, but I didn't want to do, excuse me, like an entire brim, because that would be a lot of material that we would have to take off, and I didn't really want to play with that. So I just did mouse ears, and it worked out pretty good. I'm wondering if what I set the my top Z distance as with this, because these supports seem like they're kind of stuck on there pretty good. And I got a minimal amount, but again, I put her head together, and there's our head. So we've got a lot better chance of getting this printed than trying to print this and orientate it or in some weird position. This just seems to work a lot better. So yeah. Let's see if we can. Now this has got some pieces on here. The supports on this are, got a delicate finger here. Let's get rid of that. Let's see if we can. This is where that ultrasonic cutter that I'm going to review this week on a live stream. We will do that. There we go. Just need a little bit of help. A little bit of cleaning. But that turns out pretty good. We got some little scarring on there. But in the grand scheme of things, even with this delicate part, now this could be problematic if this was like 32 millimeter size. So again, you're going to have some limitations. I'll get that out of there. That's good. That is good. And so now we've got our hand, and once we get this glued together, I mean, that's pretty decent for an FDM printer. Being able to get that detail on there like that. That is not bad. We've got all our little pieces here. So I want to make sure I don't, our little dowels that we made. We don't want to throw these away because we'll use those to put our pieces together. I think I got like a set of circular dowels, and the rest are, what are those, squares? Yeah, I did squares on this one. Let's see, it's definitely skill to take some complex models, to make complex models printable and make them come out looking good. There'll be no scratches on the plate when using a razor blade. No, because of the way that this is angled, it just barely gets under there. And as long as you just keep it good. And there is that piece there. Look at that. Nice. Let's see if we can get this other piece out here. Or the other thing you could do is just let it cool. And that's the great thing about the mouse ears on here, is that you don't have a big, huge brim, which would cause problems, especially with the delicate piece. And yeah, look at how well that turned out. Not bad, huh? And oh yeah, it's gonna be nice. It will be nice. Let's do a little bit of cleanup in there. Won't be bad. There we go. That bottom piece. Just good. And the rest of these are just breaking away nicely. We have a slight little, don't want to stab my Frau Stricker. Yeah, so I'm pretty pleased with the with how this is turning out. This is pretty nice. Not a lot of post-processing. And yeah, this is looking good. We're almost done here. Can I choose where the mouse ears should be on the slicer? That's a good question. I don't know. I just chose the mouse ear for the brim option. I don't know if that's a good question. If you can place those where you want them. This one's being stubborn. Okay, we're good to go there. Maybe a little bit of sanding, tiny bit of sanding. And so now we can put his thing together. And there would be our piece. So let's see if we can focus this in. Focus. So yeah, pretty good. Pretty good details on there. And again, if you tried to print this out, I tried printing this out, you know, I kind of did like a 30-degree angle, tried to do it like this. I just got a lot of print failures with this along with other items, but by splitting up the model like we did and doing that planer cut, all of these things printed out. And this was a substantial print. I think this was like 11 hours and 40 minutes, I think. And we're able to get all of this printed and successfully printed. That's the important part. So we have all our pieces and parts. But what you can end up seeing is that we have all the pieces and parts for our model, and yeah, it is really, really good. Whereas before, you would be hating life and trying to get all these things together. So let's put these on here. We'll have to put those together. But all of the details that we end up having, and this Frau Stricker, the hand and everything that came out, the head, and again, this is, I scaled this up 200% or 250%, something like that. But if you did this smaller, you would definitely have some problems with like the hand. You might have problems with, you know, if this is 200%, imagine this piece being 100% scaled down smaller. That could pose as a problem. But all of this here is looking very, very good. So I think we did a great job on this. So that seems to be, obviously you're going to have some diminishing returns the smaller the miniature that you have. So yeah, there's that. We got some questions on the board, so we'll go ahead and we'll leave this, because again, that turned out pretty good. And we'll answer some questions. The questions that we have. Let's see. So Swedish says, can you choose the mouse ears? Can I choose where the mouse ears should be? That is a good question. So if we go back to our desktop and we're going to go to, oh, we need to bring that out. If we go to global, we'll go to others, mouse ear. Yeah, mouse ear, outer brim, outer, inner, no brim, or auto. Brim width, all of that stuff. This controls the generation of the brim at the outer inner side of the models. Auto means the brim width is analyzed and calculated automatically. I think, no, it doesn't look like you can put the mouse ears where you want it to go. I think it just automatically puts them in places where there's sharp corners, things like that. If anybody knows different, put it in the comment section. That's a very good question. But right now it just seems like it, when we do the preview, we just get the mouse ears on, you know, some end pieces, some of those. Oh, yeah. And just around some certain areas on the corners, or have multiple corners or parts that are sticking out. Those are where the mouse ears will go. So depending on the part, will kind of, it automatically does that. Fertha says, not in Creality print. If your corners have different radii, you can affect the placement by changing the quarter sharpness value. Oh, okay. So brim, object gap, angle, brim ear detection radius, geometry will be decimated before detecting. The parameter indicates the minimum length of deviation for the zero to deactivate. Okay, 1 millimeter. So, okay. Smart people, get on that. Swedish asks, how often do I use my resin printer? I don't use my resin printer right now because it's dead, and so I ordered a new one. I had the Saturn III Ultra. I went to go print some stuff to kind of get some proxies for my Warhammer Necrons that I'm going to be getting eventually, and so I could practice on painting the paint scheme. Ends up, yeah, my Saturn III is dead. So apparently resin had leaked in, moisture, electronics didn't work out too well, and so that died. So what I'm getting is the Uniformation GK3 so I can get back to printing stuff. And my daughter's got a bunch of stuff that she wants me to print. So I will be doing more of that. Swedish says it would have been a good feature that Creality could fix into the slicer. Oh, and that's, I think that's referring back to the mouse ear thing, which, if we go back to that, so we did our little mouse ear thing, and that was set to 1 millimeter. And we can see how it is on here. So let's set it, I don't know, to 5, and we'll reslice this plate and see what happens. Because the definition, the geometry will be decimated before detecting sharp angles. This parameter indicates the minimal length of the deviation for the decimation, 0 to deactivate. Yeah, so okay, so there, so on 5, we have a lot less, like we don't have like a mouse ear like right around there. We don't have a mouse ear there on that corner and that corner. So okay, so that kind of makes sense. Now, there's probably a more layman's way of doing that, but yeah, that whole decimation of geometry and all of that stuff, that lost me there. Hey, we got Corsair there, the pirate. Evening. Reslice the plate. Words that I don't understand. Reslicing the plate. So basically what we end up having is a model. And with 3D printing, you have a model like this or something else, and it'll slice it kind of like you would slice an apple or an onion with a knife. It's going to slice it this way, across this way, and the layers, you can set the layer height of that slice. So just think of it as like you're cutting a carrot or a cucumber, and you have really, really thin slices, so we're cutting it like that. And then those slices, like this one is sliced at a layer height of 0.16 millimeters. So what will happen is that the 3D printer comes along, and on the build plate, it lays down the plastic that is 0.6 millimeter layer height, and then it'll do another layer, and then another layer, and it will build up until eventually you get the figure or model that you're printing. So when you change a variable in our slicing software, so like what we end up doing here, we got a bunch of things that we can change. Okay, stop. Seriously. So we have our plate on which we're going to put down, and the printer is going to lay down that plastic layer by layer as it builds up. And so for example, let's just take a look at this. If we start at 0, and then it'll go through and it'll do layer by layer, and it builds up layer by layer, and it does all that stuff till eventually our model is printed. So that's what it talks about slicing, is it does all the math, geometry, and algorithms and magic sorcery that it does in the program. But when you change any of these variables over here, which you can have variables for layer height, all kinds of stuff there. Pretty much, it looks hard, but it's pretty much stock, except for we change the layer height. We could add the number of wall loops for an item. So if you're wondering what wall loops are, that's so we got an orange slice there, and then the yellow, that's 2 wall loops. So if we wanted it to be a little bit stronger, we could increase that to 3. But for a model like this, 2 wall loops is good. So that's what that is talking about. And we got some other stuff there. The infill density is the density, that's that red portion there, is our support structure that is inside the model. So I set that to 5%, and you have different options of different patterns. Gyroid seems to be working out pretty well. But that's, you've got that support structure, and eventually, yeah, that's how you print the model. So that's when you change a variable on this, then you have to reslice the plate because it has to take into account the changes in those variables. So it's got to do its magic math sorcery computer thing and take that into account to produce the new slices of your model. So if you change the density, if you change the layer height, or any of those other things, it has to redo the math and then kick out a code that will go to the printer, that the printer reads, and it prints out those instructions. So just think of it as the instructions and the variables. You're changing those instructions, and the final result, you have to slice the plate, which says, okay, this is how we're going to do it, and it sends it to the printer, and the printer prints it. If you change a variable, you're going to have to reslice it. That's what they call it, reslicing. So yeah, that's how that works. It's kind of cool. It works out pretty good. Ned Vendiv says, just completed a long 150-hour print project. Wow, I saw some suggestion of using clear coat on the parts. What does this do for finished products? Any impact on how parts fit if you spray individually? That's a good question, because clear coat is going to leave a layer on top of your model. So if you do like a matte varnish or a gloss varnish, that's usually you would use that after you paint something. I guess you could put it on top of PLA or some other stuff as a coating to protect that, or get a gloss, or whatever it is, some type of finish that you want. You could do that. Just depends on how thick you spray on your varnish and how many coats that you're going to put on it. Will it have an impact? I would probably, like in the case of this, I would put the model together first and then I would clear coat it. So that way you don't have any problems. But really, realistically, I don't think there's gonna be that big of a difference that if you spray clear coat, you're not gonna be able to put the two pieces together. But what you could see if you have two pieces come together that you individually varnished and put them together, you could end up with a layer line and you might have to sand that down and recoat it to get that smooth. So to get away from that, I would glue the two pieces together first, then kind of sand them down, do whatever post-processing, and then once you're all done, then varnish it, and you should be good to go, if that makes sense. So hopefully that makes sense, yeah. What have you printed? That's the question. 150-hour print project. What did you print? Zolarian from Toymaker 3D. Ooh, let's pull that up. Big print, nice model. Let's see if we can pull that up. We'll pull up a picture of that. I need a browser and Xolarian. 3D. See if we can get some images here. Ooh, look at that. That is going to be interesting. Ooh. Wow. Yeah, I get it. Yeah. Just, okay, I got it. Leave me alone. I just want to see the picture. So, wow, that would be big. That is a big print. Wow. So yeah, definitely some cool stuff. So if you haven't done so already, check your coffee thing. Coffee thing. I will do that. Coffee thing. Seriously? Really? Corsair, you are too kind. So, you didn't have to do that. Seriously? Really? So this is the buy me coffee thing. And if you want to buy me coffee, you can do that. And look at what Corsair did. You bought me 10 coffees. I'm going to be, with all that caffeine, I'm going to be jonesing. I'm going to be shaking. I'm going to be like Hammy. Mad Mick did 10. Mike did 3. Ferrithus bought me a coffee a while back. Mad Mick did again. So we got a number of people that, bought me coffees in the past and stuff like that. Terry, I mean, you guys are too nice. You guys are too nice. So yeah, Brian, 20? That's insane. And that is just, dude, that is just too, whoa, what do we do there? You got all kinds of crazy stuff going on. Corsair, that's way too much, dude. That is just way too much. But thank you for that. Thank you. Ned Venom says almost 3 foot tall, over 10 pounds for the model that he was doing. That's pretty well. I think you got a Christmas coffee from me. Yeah, did. Thank you. Yeah, appreciate that. Awesome. Swedish. Yeah. Corsair says he's learning stuff. That's good. That's good. At least I'm good for something, right? But yeah. Yeah, I don't know. Thank you. Thank you very much. I appreciate that. What we'll end up doing with that coffee money, what we'll end up doing is taking that and we'll apply that to some durable goods. I know I've taken some coffee money and some YouTube money. I haven't figured out how to get my YouTube money into my bank. It's there. It's not much, but I'm having a problem on how to figure that out. So, because it won't send it to my military shipping address, mailing address, and the bank that I have is a credit union, and the little routing number thing that they got going on, they need a different number, and the credit union doesn't have that special international BIC number or whatever. So anyway, eventually I'll get that stuff. But yeah, we'll be adding some of the nickels and dimes and the coffees. That is way too much. That is way too much coffee. Like I said, the best thing that you all can do is just like and subscribe to the channel. You know, like the videos, but I really, really appreciate the coffees. So yeah, good stuff. Yeah, learning stuff is good. Learning stuff is good. So, and a lot of the earlier coffees actually came from people that are similar, like my wife and I. They like the information that we shared in regards to retiring in Korea, used the visas that we used, shopping for our apartment, kind of life in Korea since we're retired over here. And not a lot of people did that. I think when we decided to come here to Korea, there was a blog or a forum blog or something that I found online that a guy had done like 10 years ago. So there wasn't anybody who had come to Korea recently like we did. And so I decided, hey, let's make some videos. We'll do that, share. At least it'll help somebody. You know, if somebody does want to come to Korea like us, small niche demographic, but a number of people have done that, and they really appreciate the videos. So yeah, that's awesome. A bunch of people, if you're interested or you're in a similar situation, you know, you have a spouse that has Korean ancestry, you can use an F4 visa for the person that has Korean ancestry, and then the spouse would be able to get, it used to be called an F1, and now they call it an F3 visa, that you can stay in Korea. And of course you have to have income to support yourself, so it's kind of like retirees. So again, that's kind of a smaller niche even then. But chatted and talked with a number of people online doing video chats, phone calls, stuff like that. I don't charge for any of that, so but a bunch of people buy coffees. And then you got the cool people that do 3D printing and stuff and are just good human beings and bought me coffee. So yeah, that's cool. I appreciate that. So anyway, yeah, thanks for the likes and the subscribes. I really, really do appreciate that. And hopefully some of the information that we've gone over, kind of like, you know, how to cut these miniature files to get a print on an FDM printer, that is just works great. Instead of trying to get the FDM file or the STL file and trying to orientate it in a way and then having so many problems printing, we can see that doing that planer cut really just makes it so much easier. So yeah, the model that we ended up printing was this guy here. You know, I kind of reduce this down. I got it off of My Mini Factory. But yeah, we're able to print that out on our FDM printer, and that's a pretty involved print. So yeah, it is a very interesting print that we ended up doing. And getting all those details, and again, using the planer cut, because there are so many parts in that thing. Let's see, where's the, is that it? Yeah, there it is. So when you break that down, you have all these different pieces that you usually would print on a resin printer, and we're able to print that out using our FDM printer. Granted, it was at 200% scale, but it worked. So as opposed to trying to orientate those parts like you would in a resin printer, it doesn't work. Those two things don't go together. So yeah. Oh, and then I did have another question from somebody, not here on this stream, but who sent me a message, and they'll probably see this, talking about pre-supported files for resin printing. Can you use those on the FDM printing? So for example, Let's go ahead and we'll get rid of that. And we'll go back to our model. And you can see I went ahead and I did that print. That's the one that we did. There's another model that I just split up that I want to do. But let's go ahead and we'll take this. We'll select all these. We'll delete this. Yes, I want to delete everything. Yes. Yes. You know, I just have a thing that says yes to all. But when we have pre-supported files, which are files for your STL, your miniature, your model that already has supports on it, can you do that with an FDM printer? Here's the problem. Let's just grab one of these in here and we'll take a look at that. So there is the picture of the hand that we ended up doing. And you can see it already has those supports on there. The problem is this is generated for a resin printer and you're looking at layer heights of 50 microns, which is kind of like a human hair. So the detail on these are insane, and where these supports contact the model that we see right there, that is really, really, really small. And on FDM printers, and especially when we look at the supports like these pieces here, those aren't going to translate well into an FDM printer. This is for a resin printer. Now, some people I've seen online where they talk about, and there's like Fusion 360, and then there's a plugin that you can use for Fusion 360 that it'll change the supports from a resin printer, and somebody has done some magic math sorcery. So the plugin, you hit it and it creates and adjusts the supports on this and makes them for like FDM printing. I haven't used that. That's beyond my pay grade, but there's people that spend a ton of time on that, but you can end up doing that as well. So have I done that? No. But if you see pre-supported files that we see like this, that would all be for a resin printer. And again, what you're talking about is a very small piece. And again, the accuracy is like 50 microns. So that is kind of the crazy thing. So yeah. Get rid of that. And Bree, 19743 from the UK, watching and learning. Love your content. Well, thank you. Thanks, Ed. Good. Having more good people here is good. Venom says the model is quite interesting. Your oriental parts are glued, but almost using screw type tension. Oh, okay. Oh, he's talking about the model that he ends up doing. Swedish says he saw a video about it. Is it possible to print support in an FDM printer? Yeah, there's that. I think there's a few videos out on that for resin printing. So yeah, making a resin printed model that is pre-supported for that for a resin printer, put it into Fusion. There's a plug-in that automatically does the magic computer sorcery thing and kicks it out so that you can print it on an FDM printer, which doesn't guarantee a successful print, but it greatly increases your odds of success. But with something like what we're doing here, I'm simple. So again, I'm not the sharpest knife in the drawer, more like a spork, but we're able to go into Creality Print, a slicing program, take a complex model like this, where we would have a high chance of failure. And if we split those models in half with a planer cut and put those flat surfaces on the build area, then we're able to print everything out and we had 0 failures. So if we check that out, that just works out great. So yeah, that's what we got going on. So with that, it's about 9:35 here. So hopefully you learned something. I had some fun. I learned some stuff with this. And because that whole Fusion 360 thing is way outside of my wheelhouse, I needed to come up with something simple to give me a better chance of success when printing stuff on an FDM printer. So yeah. Swedish Ford says, if I remember correctly, they changed the resin support from resin support to be thicker so that it could be printed on an FDM printer, which is exactly true. So again, it does that magic computer math thing, and it was able to, you know, make those adjustments. And again, you're able to print miniatures with better success than using that. Ferrith says, have a good day, Steve. Dinner time there. Ah, yes, good dinner. I haven't even had breakfast yet, so I will be doing that as well. Ned Venom says, have a great day all, and I will echo that sentiment to everyone. That is really good. Again, thank you much for the likes on the video, the subscriptions. I really appreciate that. If you want to contact me, you can hit me up right here. This is my email address, officialtheverylife@gmail.com. So if you're printing out cool stuff, painting miniatures, or you have questions about retiring overseas, or you just want to say hi, that's where you can contact me. Usually I respond pretty quick. These are the people that made, I need to update the list now because Corsair bought me 10 coffees. Much respect. So yeah, thank you very much for that. You can do that, link in the description. But like I said, like, subscribe, that would be the absolute best thing you could do. Swedish has got the last comment. He says, the bed for me and for you, Steve, have a nice day. And for everyone else, I hope that you end up having a nice day. Appreciate it, and we will see you on the next video. All right, peace. Good stuff, good stuff. I love the people here. Everybody's so good and cool. I just feel at home. All righty, we will see you on the next one.